Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. We have started with chapter number 6 from physics in our previous session, Refraction of Light. We have covered the topics of Introduction to Refraction of Light by considering a small activity of a transparent glass filled with water and then dipping some portion of the pencil in a vertical way and then in an inclined position. Then we have studied about the laws of refraction, refractive index, and about the local and large scale effects of atmospheric refraction. Topics to be covered for today are dispersion of light, formation of rainbow, and if time permits we are going to start with some portion of discussion of our textual exercise. So as usual, in the first 5 minutes we are going to revise the topics which we have covered in our previous session, and then we will proceed with the explanation for our today's new topic. So the first definition which we have studied in the previous session is refraction of light. What is refraction? Light changes its direction when going from one transparent medium to another transparent medium, which is called as refraction of light. As I have told you from the lower classes, you have studied that generally light, it always travels in a straight line, and because of this, if an opaque object it lies in its path, a shadow of the object is formed. We have also seen in the lower classes how these shadows they change due to the change in relative positions of the source of light and the object. But in this lesson we have seen how a light ray can bend under some special circumstances, and that is nothing but the bending of a ray of light is refraction of light. Here you can say the criteria stands is that it travels from one transparent medium to another transparent medium. Next we have studied about the laws of refraction by taking a small glass slab. So air and glass are the two media over here. The first law states the incident ray and the refracted ray. This is the incident ray entering the glass slab, that is the medium glass from the air, at the point of incidence N are on the opposite sides of the normal. You can see this normal N, incident ray and refracted ray are on the opposite sides of the normal to the surface of the slab at that point. So what you can infer here is the CD, line CD, then and the 3, that is the incident ray, the refracted ray and the normal, they all lie in the same plane. Second law states for a given pair of media. Now here the pair is air and glass. The ratio of sin I is what? Angle of incidence, to sin R, that is angle of refraction, is a constant. And here, as I have told you, I is the angle of incidence, R is the angle of refraction. So sin I upon sin R is constant, which is denoted by a small n. It is called as refractive index of second medium with respect to the first medium, and the second law is also called as Snell's law. And I have told you here, direct question can be asked about the laws of refraction, or they will provide you with this glass slab experiment, and from that they will ask you different questions based on this topic. The next we have studied a small formula, how to calculate the refractive index. Now first case you can see refractive index of second medium with respect to the first medium is nothing but the velocity of light, refractive index of second medium with respect to the first medium is the ratio of velocity of light in medium 1 upon velocity of light in medium 2, that is V1 upon V2. You have to take care here that V should be a small alphabet as it is velocity. In the 9th standard you have studied all the small denominations, how this physical quantities are denoted. And if the first medium is vacuum, then the refractive index of medium 2 is called absolute refractive index and is written as small n. Then we have studied about the atmospheric refraction and its effects. The first small scale effect was the formation of mirage. I had told you what is mirage. It is the deceptive appearance of a distant object or objects caused by the bending of light rays. So here this effect is seen especially in the summer season, where the air near the hot road or the desert surface, and in the second case flickering of objects beyond and above a holy fire. So the air near the holy flames is hot and hence it is rarer than the air above it. So what happens in this case? The refractive index of air keeps increasing as we go to increasing heights, and hence in the first case, that is the formation of mirage or mirage, the direction of light rays coming from a distance, they keep changing according to the laws of refraction. And how they appear? The light rays coming from a distant object, they appear to be coming from the image of the object inside the ground. You can see here in this figure. So this were the two small scale effects of atmospheric refraction. The large scale effect, first one was about the twinkling of stars. I had given you the entire explanation how stars are self-luminous. They shine with their own light, and the starlight which comes towards us, it has to travel from a rarer medium to a denser medium, and constantly the starlight, it bends towards the normal, and this makes the star appear to be higher. You can see the apparent position of a star in the sky as compared to its actual position. Now this apparent position of the star, it is not stable but keeps changing a bit because of the motion of the atmospheric air. You know, atmosphere is not steady, so the air keeps on moving, and due to it the density, the temperature of the air also changes. Because of it, what happens? The refractive index of air keeps changing continuously, and because of this change, the position and brightness of the star keeps changing and the star appear to be twinkling. Do they really twinkle? No, they appear to be twinkling. And I have told you, look at this diagram which is given in your textbook on page number 76. They can ask this diagram, they will draw the diagram for you, and this 4 blocks they will keep empty. You have to label it. They will provide you with the numbers A, B, C, D or 1, 2, 3, 4 anyway. This was told to us in the meeting, so take a note about this diagram. And then they will ask you to label the given diagram of effect of atmospheric refraction. In such a case, when only labeling is asked, you will only put the number, proper number, and you will give the proper label, that is atmospheric layers, apparent position, horizon and the real position. So in this way, different type of tricky diagrams, tricky questions are asked in the exam. The next is about the planets. Both stars and planets, they are located in the sky, but stars appear to be twinkling whereas planets do not twinkle. Why planets do not twinkle? Because as compared to stars, planets are much closer to us, and hence they do not appear as point sources, but they appear as a collection of point sources. So what happens if the intensity of light from one point source decreases, it increases from the other point source, keeping the average intensity same, and hence planets do not twinkle. And the last effect we have seen is about the advanced sunrise and delayed sunset, which increases the duration of day by 4 minutes. So up till here we have completed in our previous session. Now we begin with the explanation of our today's main topic, dispersion of light. To explain or to understand this phenomenon of dispersion, just a small activity, a plastic scale with which you draw lines. Hold that plastic scale in your compass in front of your eyes and see through it while turning it a little bit. Turn it by small angles. You will see that light rays are divided into different colors, and these different colors are observed in the following order. In the lower classes you were seeing this different light shades, light colors through the plastic scale. So the first order here is violet. You can see here in the form of a rainbow. Vibgire, you have studied Vibgire. So violet, then indigo, then blue, green, yellow, orange, and finally you see the red color. Now all of you have studied that light is an electromagnetic radiation and wavelength is an important property of radiation. So the wavelength of radiation to which our eyes are sensitive or human eyes can see is in the range between 400 to 700 nanometers. Now when you speak about the different colors of light, the red light has the maximum wavelength, that is about 700 nanometer, whereas the violet light has the smallest wavelength, that is about 400 nanometers. This part you have to remember as it can be asked under MCQs, or about the first one it had been asked in one of the board exams, I think March 2020, as a true and false. So 700 nanometer was not given over there, some 300 or 400 value was given. You had to identify whether the statement is true or false. If false, you had to correct it. So such small things, but you have to remember it carefully, that red light has the maximum wavelength 700 nanometers. Violet light has the smallest wavelength, about 400 nanometers. At the same time, you have to remember one more conversion. 1 nanometer is equal to 10 raised to minus 9 meter. When you speak about vacuum, in vacuum the velocity of light rays of all the frequencies is the same, because there is no atmosphere over there, no air. But the velocity of light in a medium, it depends on the frequency of light, and thus different colors travel with different velocity, and hence the refractive index of a medium is different for different colors. Remember carefully, again this statement can be asked as a true or false. The refractive index of a medium is different for different colors. So when the white light coming from the sun, it enters the air, enters any refractive medium, it emerges as a spectrum of 7 colors. So we are going to study about this phenomenon of dispersion of light. Here the phenomenon of dispersion of light was first tried out by the scientist Newton. He was the first person to use a glass prism to obtain sun's spectrum. When the white light from the sun is incident on this glass prism, see it is traveling from the sun, it is traveling through the air and then entering into the glass slab. So two different media are seen. So when this white light, it is incident on the prism, different colors you can see bending through different angles. Clearly you can see this is the sunlight entering incident on the glass prism, and each color you can see bending at different angles. And among these 7 colors, in a rainbow there are 7 colors. The red color, it bends the least, you can see here, whereas violet color, it bends the most. Thus you can see here in this figure, all the 7 colors, they emerge along different paths. This is the path for red color, then orange, then yellow, then green. and get separated. So 7 colors emerge along different paths, get separated, and hence we get a spectrum of 7 colors or a 7 colored rainbow. So this 7 colors which are obtained on dispersion is called a spectrum. And what is the definition for dispersion of light? The process of separation of light. This sunlight is separated into its component colors while passing through a medium. Here the medium is a glass slab, is called dispersion of light. Disperse, separated. See the meaning. The word also itself has its own meaning. The process of separation of this white sunlight into its component colors after passing through a particular medium is called as dispersion of light. Now based on this topics, they can ask you a neat label diagram of dispersion of light. Here you have to take care. You should not use any color in your answer sheet, board answer sheet or your school exams. You have to only label the names of the colors. You can use black colored pen, blue colored pen or a pencil. Apart from this, any other color is not allowed in the board answer sheet. So even if you have to draw any diagram where you have to color or something, do not use any color. Only you show the color by writing that particular word. Here you can show red, R-E-D, red, then spelling for orange, that way. So take one care. Next is about, they can ask definition of dispersion of light. Then looking at the diagram, answer the following questions. Which color bends the least? Which color bends the most? What is the spectrum? What is this phenomenon? Define the phenomenon. Or in the beginning, as I have told you, what is the wavelength of red light? What is the wavelength of violet light? Different true or false? Match the columns or MCQs. So this topic is extremely important for the board exam. Study it in all the terms. Now we move on to the next topic, partial and total internal reflection. Partial and total internal reflection. Here you can see a diagram. Different media is shown, air, and this light rays are entering from the air into the other medium, that is water. So the first topic here is partial and total internal reflection. The word itself tells you partial means some part of the light gets reflected, and let us see about total, how the entire light rays it gets reflected. So when light enters a rarer medium from a denser medium, rarer, suppose you take air and water, then air is the rarer and water is the denser medium. So here first we will assume when light enters a rarer medium from a denser medium, it gets partially reflected. Means what? The part of the light gets reflected and comes back into the denser medium as per the laws of reflection, and this is called partial reflection of light. The main criteria to be followed here is that light, when it enters a rarer medium, from which medium? From the denser medium. See, water is the denser, air is the rarer medium. From the denser medium into the rarer medium, what will happen? It gets partially reflected, and means what? The part of the light, it gets reflected. You know what is reflection, and again comes back into the denser medium, which is known as partial reflection. Now, as light is going from denser to rarer medium, it bends away from the normal. That is, the angle of incidence is I. It bends away from the normal. You can see when the light is going from the denser to the rarer medium, it bends away from the normal. The angle of incidence is I, which is smaller than the angle of reflection, that is R. This is the angle of reflection, R. You can see here in this diagram on the left side of the figure. This is figure 6.9. which is given in the textbook. On the left hand side you can clearly see angle of incidence, angle of reflection. If we increase the value of I, that is if we increase the angle of incidence, R, that is angle of reflection, will also increase according to Snell's law. Why? Because refractive index is a constant. So if one is increasing, the other will also increase. For a particular value of I, for a particular value of angle of incidence, the value of R becomes equal to 90 degree. For a particular angle of incidence I, the value of R, it becomes 90 degree, and this value of I is called as the critical angle. You can see here IC. For angles of incidence which are larger than the critical angle, the angle of diffraction is larger than 90 degree. Such rays you will see return to the denser medium. As you can see on the right side of this figure, all the light gets reflected back into the dense medium and all the light rays come back, and hence it is known as total internal reflection. This phenomena, how we are going to apply in a small topic ahead when you study about the formation of rainbow. I hope you have understood about partial and total internal reflection. The first thing is, when the light rays enter the denser medium from the rarer medium, what happens? Partial reflection is seen. When this light is going from the denser to a rarer medium, what happens? It bends away from the normal. So the angle of incidence I here is smaller than the angle of reflection. If you increase this value of I, the value of R will also increase, because according to Snell's law, refractive index is constant. For a particular value of I, the value of R will be equal to 90 degree, which is known as critical angle. For angle of incidence greater than critical angle, what will happen? The angle of diffraction is greater than 90 degree, and such rays return to the denser medium, and this is known as total internal reflection. The last topic to end this chapter is a very beautiful topic, formation of rainbow. You all have witnessed a beautiful 7-colored rainbow in the sky, especially after a rain shower. So what is this rainbow? It is a beautiful natural phenomenon. But when we speak about the rainbow in scientific terms, it is a combined effect of 3 natural processes, that is dispersion, refraction and total internal reflection of light. This rainbow is a combined effect of 3 processes: dispersion, refraction and total internal reflection of light. Now this rainbow is seen mainly after a rainfall, where small water droplets which are present in the atmosphere, this is a water droplet. Now water droplet, so it is a transparent medium, they act as small glass prisms. So when light rays from the sun, this is a light ray coming from the sun, they enter into this droplet, it gets refracted. Now light rays traveling from atmosphere into this water droplet. So there is a change in the medium. So what will be the first phenomenon? It will be refraction. So the light ray gets refracted and dispersed. You have studied about the dispersion of light earlier. Then there is internal reflection. You can see here inside the glass droplet you will see internal reflection, and after that once again the light gets refracted while it comes out of the water droplet. So all these 3 processes, that is dispersion, refraction and total internal reflection of light, they produce the beautiful 7-colored rainbow in the sky. So when a topic is asked on this formation of rainbow, if they ask a direct question, explain the phenomenon of formation of rainbow, your answer should be supported with a small diagram, or The another type of question asked here will be a diagram will be provided to you, and based on this diagram they will ask you identify the phenomenon based on refraction of light. Then it is the effect of which three natural processes, how these processes take place, which are the two media which act to form the rainbow. So these are the different types of questions which can be asked on this topic. Similarly, if you have to speak about the previous topic, that is partial and total internal reflection, they can provide you this diagram. Surely they will not ask you to draw this diagram, and based on this diagram, what is partial reflection, what is the critical angle, what is the total internal reflection, such type of questions will be asked in the exam. So be prepared with it thoroughly. With this we complete with the explanation of chapter number 6, that is refraction of light. So without wasting a single minute, let us begin with the textual exercise. The first question is, fill in the blanks and explain the completed sentences. You only don't have to fill up, you have to explain, give the explanation. So the first is, refractive index depends on the dash of light. Refractive index, it depends on the velocity of light. You have studied this. Answer is on page number 74 in your textbook. Last line, you can see page number 74. Last line is given in bold black font. Refractive index depends on the velocity of light ray. What explanation you can give here? Refractive index of the medium is inversely proportional to the velocity of light. As the refractive index of a medium increases, the speed of light going through that medium decreases. Anyway, this is the explanation which I felt relevant for this fill up. Any explanation to support your answer you can give. It should be logically and scientifically correct. Second one, the change in dash of light rays while going from one medium to another is called refraction. So the change in direction of light rays, you can see page number 73 of your textbook, the definition which is given in bold font, bold black color, that is your answer. So in short, you can write the definition for refraction of light. Light changes its direction while going from one transparent medium to another transparent medium. This is called the refraction of light. Page number 73, bold black font, definition of refraction is your explanation for the second fill-up. I hope all of you have followed. Now we move to question number 2. Question number 2A is slightly lengthy and difficult, so that we will take up in our next session. So today we will just complete question number 2B. It is very simple. Take the textbooks in your hand to mark the answer. They have asked, prove the following statements. So the second one we are attempting here. A rainbow is the combined effect of the refraction, dispersion and total internal reflection of light. As I have told you earlier, when such a type of question is asked based on rainbow, first you will draw the diagram. Again, I have not drawn here on this slide because just now when the explanation was completed, I had told you about the diagram. So the diagram which you are going to draw is 6.10 from page number 78. Now mark the answer. Page number 78, last paragraph of that page. The first point is, the beautiful natural phenomenon of the rainbow is a combination of different phenomena: dispersion, refraction and total internal reflection of light. Now the first three statements, do not write everything as it is given in the textbook. I have told you in the live session also yesterday that how to decrease the length of the statement and cover up all the concepts. That is the art which you have to express in your answer sheet. Second point, continue marking. It can be seen mainly after a rainfall as small droplets of water act as small prisms. Third point, continue marking. When light rays from the sun enter these droplets, it gets refracted and dispersed. Just add this 3-4 words, that results in a spectrum. Fourth point, continue marking. Then there is internal reflection inside the droplet. and after that once again the light gets refracted while coming out of the droplet. As a collective effect of all these three processes, a beautiful rainbow is formed. Means in short, you highlight all the points of the last paragraph on page number 78. You should see over here the main theme of the answer is this phenomena: dispersion, refraction, total internal reflection. For writing this part you will have marks. Then who is acting as glass prisms? So when this rainbow is seen, what happens actually in the formation of rainbow? So this part is very important, and support it with a small diagram, that is figure 6.10. With this we will wind up with our today's session. In our next session on Saturday, we will continue with the discussion of textual exercise. I will be also discussing the additional questions for this chapter with you. Then we will finish the activities for this chapter, and towards the end I will take up the solved examples and the textual numerical examples. So most probably by Saturday we will complete this chapter, and then next week we will start with a fresh new chapter, chapter number 3, types of chemical reactions. On Friday you are going to get experiment number 1 from section A. So see to it, go through the video carefully and complete your journals on time. Thank you, dear children.